everyone. Today we will be discussing experimental probability. So what is experimental probability? Well, experimental probability is kind of like what it sounds like. It is based on repeated trials in an experiment. So experimental probability is based on doing experiments and the trials that happen. Probability. Experimental probability is based on the repeated trials of an experiment. Repeated trials of an experiment. So this means that you do an experiment and you record the data from every single outcome. It's very similar to what we did with relative frequencies. So it's very similar to the relative frequencies. So repeated trials of an experiment. So when we're looking for this, we're going to use the equation that says the probability of the event. Remember, the event could be like rolling the dice or flipping a coin or doing the spinner. It's so the probability of the event, so P of the event, is equal to the number of times the event occurs over the total trials. Okay, so maybe my event is rolling an even number. So what's the probability of rolling an even number? Well, let's say that I roll an even number 6 times out of 10. So the experimental probability is 6 out of 10, or 60%. Let's look at an example so you can see this in action. So example number 1. Example number 1 says that we are going to flip a coin. And as we flip our coin, we have heads and we have tails. Okay? We flip heads 6 times in this experiment, and we flip tails 19 times. They want to know what is the experimental probability of flipping heads. So what is the experimental probability of flipping heads? So what we're going to do is we're going to look and see, well, how many times did we already flip heads? Well, when we look at this, it looks like we flipped heads 6 times. So the probability of the event, which is the probability of heads, is 6 out of, 6 plus 9, that gives us a grand total of 25. So 6 out of 25 times we flipped heads. 6 out of 25. Okay, so 6 out of 25 times we flipped heads. Okay, now we're looking at what this would look like as a percentage. So we're going to take 6 out of 25 and we're going to set this up as some percent over 100. You can use the fish method, you can use cross multiplication, however you want, but we're going to do 6 times 100 divided by 25. That gives us 600 divided by 25, or a total of 24%. So 6 out of 25 is equal to 24%. So the experimental probability of flipping heads is 24%. So you just go through, figure out how many times you tried, what the experiment was, it's flipping heads, how many times did we do it? It's always going to be out of 100. So if we were to do this out of 100, we would get 24%. Okay, let's do another example. Example number 2. Example number 2 is that we are rolling a number cube. So in example number 2, we are going to roll a number cube. This is also known as a dice, or a die, just one. Okay, the number rolled and the frequency. So after we do our trials, this is the data that we collect. So here's the numbers rolled, and how many times after 30 rolls? So the frequency. So a 1, a 2, a 3, 4, 5, and a 6. It says that we rolled a 1 2 times, a 2 5 times, a 3 7, a 4 6 times, the 5 we rolled 5 times, and the 6 we rolled 5 times. So the total number of rolls was 30 total. Okay, so we did 30 total rolls. Now, the experiment that it wants us to look at is what's the probability of rolling a multiple of 3? So the question is, what is the experimental probability of rolling a multiple of 3? Okay, so we're looking at the probability of roll. Okay, so is 1 a multiple of 3? No. What about 2? No. What about 3? 3 is a multiple of 3. Not 4, not 5, and 6, because we can do 3 and 6, right? 3, 6, 9, 12. So those are our multiples. So the multiple of rolling a 3 and a 6. So we're going to look only at the 7 and the 5. So we rolled 7 plus 5, which equals a total of 12 rolls. So we rolled 12 out of 30. So 12 out of 30 is our roll. Now, when we did 12 out of 30, now we're going to come back up here and we're going to do the same thing to find the percentage. So 12 out of 30 is out of 100. We're solving for x. So 12 times 100 divided by 30 equals, we can even use our calculator here. So that's 1200. So 12 times 100 is 1200 divided by 30. And that's going to give us 40%. So 40% is our total. So if we go like this, divided by 30, and that equals 40. So 40% probability of rolling, experimental probability of rolling a multiple of 3. Okay, go ahead and finish writing this example down, and then when you are ready, turn the page and we are going to do a try it. So get ready to do your try it. All right, and for the try it, our try it says, what is the experimental probability after we roll a number cube 50 times? So rolling, oh my gosh, I never moved this. I'm so sorry. Okay, so we're going to roll the number cube again. These are the results. So the results, the number rolled, and here is the frequency, so how often it was rolled. We have a 1, we rolled that 10 times. We have a 2, we rolled that 4 times. A 3, which was rolled 8 times. In this experiment, the 4 was rolled 11 times. A 5 was rolled 11 times. And a 6 was rolled 6 times. For a total of 50 rolls. So we had a total of 50 rolls. All right, our job now is to figure out what is the experimental probability of rolling a 3. And I also want you to answer the question of what is the experimental probability of rolling an odd number? Okay, go ahead and hit pause right now so you don't hear me solving, and then when you are ready, come on back and check your work. All right, so when we rolled a 3, we rolled 8 threes. So we rolled 8 threes out of 50, and we can multiply by 2 to get us to 100. We multiply by 2 on the top, which is 16, so it equals 16%. We rolled a frequency of 16%. Okay, rolling an odd number. So let's look at the ones that are odd. 1 is odd, 3 is odd, 5 is odd. So we have 10 rolls, 8 rolls, and 11 rolls for a total of 29. So 29 options. So we had 29 out of 50. So when we have 29 out of 50, we are trying to get to 100, right? So times 2 and times 2. So x equals 29 times 2, which is 58%. 58%. All right, how did you do on solving these two problems using the information up above? How did you do? Go ahead and rate your level of understanding out to the side. Where are you at out of 3? Answer your essential question. What is experimental probability? And then rate your level of understanding out to the side. When you are finished, you can come on back to the Google Meet and ask for help, or you can go and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.